Hey guys, this video is regarding the how to implement single pass assembler using SIC. I'll explain the concept behind it. Firstly, we need to know what an assembler is. It's a program that accepts as input an assembly language, which will be our source program, and then it will produce its machine language equivalent, that is the object code. Uh, then the advantages are it provides more control over handling particular hardware components. It may generate smaller, more compact executable modules. Now the algorithm that I followed is I first give an input file. It will open and read it using the input buffer package. Second is if the input line has the opcode start, it will check if there is an operand value. If there is call start, then it will uh, give the LC value, or it will locate the location counter value to it, or else it will set the location counter value as 0. Then it will write the input line to the intermediate file which I have created way before. It will read the input lines from the input.txt file, which is here. This is my input.txt file. It's an assembly program, and it will read one line from this, and it will give to this intermediate file inter.txt. Then it will write the input, and it will check the symbol table. If the symbol is not available, then it will enter the symbol into the table along with the memory address stored in it. Now till this I'll explain the code. We have imported all the necessary packages needed. Then we have created the hash table and object of OP and SYM, which symbolizes the symbol table. Then I have given my input file input.txt, which contains the assembly program. It will read the single line, means each and every line from that file, and then after that it will check if the starting opcode is start. It will locate, or it will initialize the location counter to it as 0. Then it will start executing. It's exactly similar to the algorithm that I explained it. Then moving further, it will check if there's an opcode or not in the assembly program that I have written. Since here we can see there's an opcode, LDA and STA. So what will it do when it detects those two things? Now if it is present in the opcode table, then it will increment the LC by 3, and it will write the location counter, then opcode and operand fields of the corresponding statement. Then if the opcode is word, then it will increment LC by 3. If the opcode is byte, it will increment it by 1. If it's reserved word, it will increment the LC by an integer value, and it will multiply the operand value by 3. The code till here is, I've written it. If the line contains start, it will while producing the object code, it will give a header H as the format, because that's the format of producing an object code. Then it will convert any value address to the hexadecimal value. I have used here 2 hex string for that purpose. And then when if the line contains end, it will give E as the end record. So by that the compiler can judge whether the end of the record has come up or not. Then yeah, this is the code that for which I explained you the algorithm. If the location counter, if it's reserved word, it will increment the location counter by 3. If it's just the word, it will increment the LC by 3. So here if it's reserved word, it will LC plus equals 3. It will add the location counter by 3, and so on. Then it will return that location counter. After that, if the opcode is reserved byte, then increment LC by integer equivalent. If there is no symbol at all in my assembly language program, then the operand address is assigned as 0. Now write the processed lines in the intermediate file. All the lines that is being read from my input.txt to the inter.txt, you have to process it along with their location counters. Now in order to find the length of the program, we need to subtract the starting address of the program from the location counter. Then we'll close all the files. Program till this algorithm is here. if it's I've created a method here, ready opcode table means it will throw an exception. I have created an object for hash table and buffer reader. Again it will read the opcode file now, opcode.txt. Now it will see if the line that it reads, if it's not equals to null, then it will split it according to the delimiter given, and then it will put all the strings into an array. So like that it will generate the object code to us. This is a required output. My input file was this. So here header, it's detected as copy, and then it gives its address value and the operand value. Then the text, both the opcodes value, that is STA, LDA, and so on. It gives its address and the operand value. Then the end of the record, it gives its address value. So this was all for this experiment. Thank you.